Hey guys, we're going to talk about something called a phylogenetic tree, which you've probably heard about. Maybe not that word, but in biology it's called the tree of life. Sometimes it's also called a cladogram. And I just want to show you how they work, what they mean, so that you can interpret them and understand what they are and what they tell us. So a phylogenetic tree looks something like this. And what it is this is a visual representation of how life here on Earth has evolved over time, all right, and how species are related to each other. So it shows us time, so like earliest species here, and it flows in this direction to the newest species. And it shows us how species have branched off from each other, who our common ancestors are, and how closely related we all are. Okay? So I want to show you sort of a key for this phylogenetic tree. So the first thing is that you see at the end of each of these kind of green lines is a letter. Sometimes you see a picture or the name of a species, but the end or the terminal of each branch represents a species. All right. And then we have these little green dots here. Where these green lines meet, they're called nodes. All right. The lines, each of these lines that the orange arrow is pointing to, is a branch, okay? And then here at the very beginning, the earliest species, we have it's called a root, all right, which makes sense. It's kind of the base of the tree. It's where everything starts. So here's what you need to know about these things. The first thing is that all of these green lines are showing us, we started out with one species, and it shows us the path that evolution took. So here we may have had some sort of bird, but maybe that bird was kind of, that population was separated and divided by a mountain range or a river or some kind of forest. And so over time they become really different from each other because they evolve differently in their different environments. Until suddenly at one point they've become separate species, okay? So completely separate species. So here you have a branching point where species go in different directions and evolve differently. Now, every node where you see the branches dividing from each other represents a common ancestor. Okay, what that means is that all of these species at some point shared a common ancestor here, but then they went in different directions. But they all came from the same thing. Okay, same here. All of these species shared this common ancestor until it branched in different directions. These guys shared a common ancestor here. These guys shared a common ancestor here. And the more close together your common ancestor is in a phylogenetic tree, the more closely related you are. So A and B are fairly closely related. C and D are closely related. A, B, C, and D are more closely related to each other than E, because its common ancestor is way back here, whereas these guys all share one here, these guys share one here, these guys share one here. So hopefully that makes a little sense. So let's talk about an example. These two are fairly closely related. So let's say that A represents dinosaurs and B represents birds. Birds and dinosaurs are actually fairly closely related. So they diverged. They had, like, birds and dinosaurs came from the same common ancestor, the same original species. Let's say that C is chimpanzees and D is humans. Now, humans didn't evolve from monkeys. Monkeys and apes, great apes, took a different path from humans. Okay, we branched off and took a different path. However, primates, humans, gorillas, orangutans, chimpanzees, monkeys, all those things, we shared a common ancestor. So if you go back further and far enough in time, hundreds of thousands of years, at some point, some species, some common ancestor species got separated and evolved differently and created all these primates, right? So primates all have a shared common ancestor. And then E doesn't share much with any of these. E is maybe like sharks. Sharks are ancient. They've been around for about 450 million years. So they branched away from these things a long, long time ago. And their common ancestor with other animals is way further back on the phylogenetic tree. So we're going to look at some of these. They get really complex, of course, because we have millions of species. But this is a simplified version of what a phylogenetic tree says and does and means. Let me know if you have any questions, but I'm going to give you some worksheets to practice this. And then you guys will be doing an activity where you design your own phylogenetic tree through a simulation. That's it. Tree of life. Thanks, guys.